Welcome to the Pocket Science channel. Hi everyone. As per request from the viewers, we have decided to do the subject differentiation and integration part by part. First of all, I am giving you an introduction about differentiation. Now, I am considering a function of x as y. Just think the function is given like this. Now I am considering a point x0 in x-axis. Then the corresponding y-coordinate is given as y0. Now when I increase this x0 by a little amount delta x, here the coordinate is x0 plus delta x, then the corresponding y value also will change by a little amount. Here I am considering it as y0 plus delta y. The initial function was y0 equal f x0. Now after changing a value of delta x, the new function is y0 plus delta y equal f x0 plus delta x. Now I am getting the increment value delta y is equals to f x0 plus delta x minus f x0, the difference of these two functions. Now I am getting the ratio of delta y and delta x. It is equal to f x0 plus delta x minus f x0 upon delta x. This is known as the incremental ratio, and the limit when delta x approaches to 0 is known as the differential coefficient or the derivative of the function at the point x equal x0. Then I can express it as dy upon dx. It is equal to limit delta x approaches 0 f x0 plus delta x minus f x0 upon delta x. To get some more clear idea, I am going through an example. Now I am taking a function y equal x square. Now if I take delta x is the increment of x and the corresponding increment of y as delta y, then I can write the new function as y plus delta y is equals to x plus delta x whole thing to the power 2. Now by following the similar way, I can write delta y as x plus delta x square minus x square. Now I am taking the incremental ratio as delta y upon delta x is equal to x plus delta x squared minus x squared upon delta x. Now the dy upon dx is equal to limit delta x approaches 0 x plus delta x squared minus x squared upon delta x. Now I can find the limit of this value. For this I am expanding this x plus delta x whole thing to the power 2 is going to be x squared plus 2 times x times delta x plus delta x squared minus x squared upon delta x. Now I can simplify plus x squared minus x squared get simplified. Then I can divide these two by delta x. Then I am having limit delta x approaches 0 2x plus delta x When this delta x approaches 0, the final value I am having here is 2x. By this way, we can say the differentiation of the function y equal x squared is equals to 2x. That way of finding the derivative is known as the first principle, and by using this some fundamentals are proved. Let's go through one by one. The first one, when y is a constant, then we can write dy upon dx is equals to 0. The second one, when y equal a constant times a function fx, then the derivative dy upon dx is equals to that constant times the derivative of that function f dash x. Then the next one, if y is addition or subtraction of two functions, here I am considering fx and gx, fx plus or minus gx, then the corresponding derivative dy upon dx is equals to the derivative of this function fx is f dash x plus or minus the derivative of this function gx g dash x. The next one, when y is equals to a product of two function fx gx, then we can write dy upon dx is equals to fx times the derivative of this function, it is g dash x, plus gx times the derivative of this function, it is f dash x. The next one, if y is a function of ratio of two functions fx upon gx, we can write dy upon dx as the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator upon the square of the denominator. The next one is when y is equals to the power of x, any power of x, I am considering it as x to the power n, then we can write the dy upon dx is equals to the power times n times x to the power n minus 1. We can use this formula directly where we are finding that when y is given as power of x or power of a function, it is when y is written as power of a function, we can write the derivative dy upon dx is equals to n times fx to the power n minus 1 times the derivative of this function. For the previous one it was just x, therefore the derivative of x with respect to x is equals to 1, therefore we are only considering this n times x to the power n minus 1. For this y equal the power of a function, we can write it as n times fx to the power n minus 1 times the derivative of that function. Now I am going to explain some examples under these fundamentals. First I am considering a function y equal x squared plus 1 times x cube plus 2. Here it looks like a product of two functions x squared plus 1 and x cube plus 2. Then we can write the derivative dy upon dx as this one times x squared plus 1 times the derivative of this part. Here the derivative of x cube, it is 3 times x to the power 3 minus 1, 2, plus the derivative of constant is 0. I am writing it as plus 0, plus this times x cube plus 3 times the derivative of this function. The derivative of x squared is 2x to the power 2 minus 1, it is 1, plus the constant is going to be 0. Now I am going to simplify this. If I remove the bracket, I am having here 3x to the power 4 plus 3x squared plus x cube times 2x, 2x to the power 4 plus 2 times 2x, 4x. I am going to further simplify this. Here the like terms, 3x to the power 4 plus 2x to the power 4, it is equal to 5x to the power 4 plus 3x to the power 2 plus 4x. Now there is a common factor x. If I take x out, I am having 5x to the power 3 plus 3x plus 4. The next question is y equal x plus 2 to the power 2 upon 2x plus 1. Now I am going to write the derivative dy upon dx is equals to the denominator times 2x plus 1 time the derivative of the numerator. Here it is expressed as a power of a function, then 2 times x plus 1 to the power 2 minus 1, it is 1, times the derivative of this function. The derivative of x is 1 plus 2 is 0, then you can write it as 1 minus the numerator times the derivative of the denominator, it is going to be 2 upon the square of the denominator, it is 2x plus 1 whole thing square. Now I am going to further simplify this. Here there is a common factor 2 and x plus 2, then I am taking out 2 times x plus 2, then I am having inside the brackets 2x plus 1 minus there is a 1x plus 2 upon this denominator is 2x plus 1 whole thing square. Then I can further simplify and write 2 times x plus 2. If I simplify inside the bracket, 2x minus x, it is x, 1 minus 2, it is minus 1, then x minus 1 upon 2x plus 1 square. Now we have learned some basics of differentiation. If you need the remaining parts of the differentiation, please keep our channel subscribed. Thank you.